Welcome back everyone. In this video I'm going to go over some of our improvements to our water system. Most notably, I've installed Flowmeters. As you can see in the yellow there, it detects the flow of our wash water, and in blue, the flow of our drinking water, and thus I can monitor our consumption and thus our remaining water levels. So let me show you how I did it. Alright, so this is our side compartment door on our big Overland truck. We've had a lot of new channel subscribers lately who may not know the context of what half of the stuff we're doing is. So this is our big Overland truck and our home for the last 2 years. It's taken us through Canada to the Arctic Ocean, through the US, Mexico, and we're heading into Guatemala here right away as soon as the border opens up. So that's a little bit of context for what we're doing, but I'll just give you a quick overview of the water keg system, because I have done a pretty exhaustive video last year, maybe 2 years ago when we were in Baja. So if you're interested in the water keg water supply, you can go check that out. I'll have a card up here presently. But I will quickly go over the changes I made recently and how that affects the drinking water and wash water supply. Alright, so it's tight quarters in here, but bear with me. We used to have all 5 of these kegs with fresh purified water, and it's not so expensive, about 15 pesos or $1 maybe for a 5-gallon fill of purified water here in Mexico. But we found that sometimes it was just in short supply and we were using too much water for washing dishes or showering or whatever. And so I decided to segregate our water supply. So I have 3 of these kegs rigged up as drinking water, and they are wired sequentially, or plumbed sequentially, so that they all drain out through those. And then these 2 kegs on the left are wash water, and that I can fill with whatever tap water I can find out of a hose. And quite typically here, tap water out of a hose comes from a well on the person's property. So while it's clear-ish and looks okay, and going through our 5-stage, or rather 4-stage water filter system should clean it up pretty good, it's easy enough just to separate it, and so that's what I've done. So I've got these 2 kegs wired with a little jumper. I can show you here. So I've just got these short lengths of hose with the ball lock fittings on them, jumpering one keg from one to the next so that they flow out sequentially. And so that's what I've done here. So here's where the Flowmeters live. Actually, give me just another second. I'm going to take these jumpers off too, just so you guys can see. These ones I've custom made to be exactly the length that they fit without too much excess. Anyway, up here is the 2 Flowmeters. And I'll maybe pull these off and show you in closer detail here in a bit once we go back inside. But here's where I have them mounted, very close to the Wemos module and near to the water supply. So here's where this all lives. Let's go inside and I'll break it down for you a little further. Alright, so back inside here now, I'll give you a little more in-depth tour. Like I said, we have separated our water supply so that this tap with the sprayer and everything, that we use for wash water and washing our dishes and such, washing our hands. And that comes from the 2 wash water kegs that we can source from any old tap water tap and not have to worry about contaminating the rest of our drinking water. And the new one is this chrome drinking faucet, and that comes from our drinking water taps. And so here I'll show you with a little more detail, refilling our kettle. You can see on the blue dials there, we're flowing about 2 liters of water per minute. If I crank this to the max, we get about 2.5 usually. And you can see our water level in the keg remaining, dropping as it's counting up the water that we've consumed. And then when the water flow stops, the blue numbers stop ticking by. So that shows our water remaining currently. It's 57.19 liters in the fresh drinking water tanks. And at the bottom, in the water usage graph there, you can see over the course of the last week, the water levels dropping and dropping. And then yesterday they spiked up again because I refilled them. And I can show you a demo of that really quick. I just have these 2 fields right here. The the wash water and the drinking water fields. And so I'll just set it to 57. And then the dial, the gauge there updates to 57, and the whole system knows that we have 57 liters left. And so in that way, I don't have just a refill button. I can fill 2 of the kegs, which are 20 liters each, and and then I can just say we've got 40 liters if we were only able to get 40 liters that day for whatever reason. So that's that. Let's jump into exactly how I did it. Alright, so I've got everything hardware-wise pulled out here just to give you a little bit of an overview of that. We'll start with the Flowmeters. I have 2 of these. Thank you, supporting channel members. And I've popped the screws off of one to pull the cover to show you. It's just very basically a little paddle wheel like you'd see on an old-timey steamship. And as the water flows through this device, the paddle wheel spins, and there's a small magnet built into the hub of the flow meter, and it gets picked up by the Hall effect sensor inside this half of the enclosure. And when the wheel spins, it pulses out of the signal wire, the yellow signal wire, positive and negative pulses, and then you need to correlate the number of pulses to the amount of water that's flowing. In my case, with this flow meter, I get 28.5, I think. Let me check this real quick. 18.226 milliliters per pulse. And so then you just need to count the pulses. Fortunately, little tiny cheap computers are really good at that. You just count up the pulses and correlate that to the amount of liquid that's flowing. Alright, so the brains of the operation. This is the Wemos D1 Mini. Long-time viewers of the channel will know this is my favorite little go-to Arduino board. It's got Wi-Fi built in and 11 I/O, I think, for the low price of $3.50, programmed simply over USB or Wi-Fi. So if you haven't seen our other videos on these, we've done a bunch, check them out up here. And there's really nothing to this circuit board. I just used a cheap piece of perf board just to make wiring a little easier. So the Wemos just plugs in there, and then I've got plugs for the flow meters and the floats and some other paraphernalia I'll show you here in a second. But there's really not much to this. It's just 3 wires and a couple little jumpers here and there, but it gives a nice fixture point to put this on to standoffs to mount it permanently. So again, there's really nothing to it. I will put up a blog post on our website with the schematics for this, just showing which pin out I have connected to which pin, but not too much too interesting here. Alright, so here it's sort of rigged up as a bench test. I've only got one of the flow meters connected, but I wanted to show you this float assembly and how that ties into this whole system. But firstly, this flow meter I've got connected to the wash water input, so you'll see on the yellow wash water level there, just below right here, the flow rate. And you can see the indicated water level is decreasing as the flow rate ticks by. So I'll take that off. The other thing I wanted to point out was this float assembly. This lives inside the last keg, and this oval piece up here is our the lid to the keg. And these are really inexpensive. I think I paid $20 for this years ago for another project, but I had it kicking around and I brought it with us, and I installed it a while ago, but it's a pretty coarse unit of measure because it just shows us when we're at our last keg. But the way I've implemented this is kind of handy because this is located in the last keg, so once the first 2 kegs are depleted and the water level starts coming down this way, this float sinks. And you can see on screen there the indicated water level drops to 19 liters. So it's self-correcting. If the flow meter's measurement was out by a certain percentage and it thought it had 24 liters but we really only have 19, then it'll self-correct to 19 at that level and indicate that the top float has tripped. And then once the water level comes lower and lower and trips the bottom float, it shows the bottom float is tripped and adjusts the water level to 10 liters, which is a little bit generous. It's probably more than 10 liters and probably at 12 or a little better than 10, but it's a safe number. So that's handy because if my flow meter is out for whatever reason, or these numbers get lost during a reboot, which should be accounted for, but for whatever reason, if those numbers go haywire, then I have this as an absolute level. When we're at 30% of our water remaining, this float will trip and be indicated here. And at 15% of our water, that float trips and is indicated here. So that's that. And then to refill the water level, again, I just type in the amount of water remaining. Whoops, the floats are still tripped. Indicate this 58 liters remaining, and it updates there. So that's that. All right, so jumping into the computer now, you can see I've got the sketch up here. This is the GitHub source that I originally used as inspiration, although it's been heavily modified since then for dual flow meters plus the floats and some other odds and ends. But I'm not going to dwell on this too heavy. If you're super interested, you can go to the website and check out the blog post for that in the members section. But basically, it's got two interrupts. Where are they here? Here we go. Two interrupts for the pulse pin wash and pulse pin drink. And those two interrupts monitor the two pins from the flow meters. And when they detect the pulse, they increase up here, the pulse count for either wash water or drinking water. So they increase the pulse count every time they count another pulse. They increase the count by 1, and then once per second, right here, it updates and sends to Blynk. So it turns off the interrupts as to not be interrupted while it's trying to do something else, and then divides the flow rate by the milliseconds that the computer's been up since the last time it was checked, divided by the flow calibration, etc., and prints out a bunch of debug data so that I have debug information up on that screen. I could probably comment a lot of that out now, but it works, so I'll leave it alone. Anyway, so it calculates the wash water used and then the drinking water used, and then updates the Blynk server with the updated values, which then get translated to our app where we can watch them. So that's really handy, and I love the over-the-air update with Blynk. You can see here the port, it's available over USB right here, but I have all of these other Wemos modules online on our network inside the vehicle here, and I can just update this one over the air. You can see at the bottom here it's uploading via the Wi-Fi's, which is so handy when I've got these things embedded up inside a fan or in a freezer controller and the other things that they're handling. So that's really handy. I'm going to get this put all back together here, but I'd like to thank everyone for watching. Thank you to all of our channel members whose names are whipping by. Couldn't have done it without you, and thank you for your patience. It's been a little harder to shoot videos. Kara's been gone in Canada for 6 weeks, and it's been raining cats and dogs here, so a little slower to put out videos than I would have liked, but thank you all so much for your patience. The members, if you're interested, Kara's put up a little video showing her trip to Canada, see family and that, so you can check that out here. And again, thanks everyone for watching. Hope you enjoyed. Leave me positive and negative comments down in the doobly-doo. We'll see you next time.